You're listening to Impulse to Innovation. The Institution of Mechanical Engineers podcast. I'm your host, Dr. Helen Mees. As a global community of mechanical engineers with over 120,000 members in 140 countries, the Institution of Mechanical Engineers has been at the heart of the engineering profession since 1847. The institution's mission is to improve the world through engineering by sharing the latest news, views, and insight into the creative world of technology and the people that make it happen. At the dawn of the Industrial Revolution, engineers devoted their efforts almost entirely to making devices that function reliably and profitably, but with little attention to safety. Yet frequent disasters, mainly as a result of the growing use of high-pressure steam, led engineers to question increasing numbers of deaths and to assess problems with the technology that they were developing. Indeed, when Richard Trevithick began experiments with high-pressure steam engines to increase both efficiency and power, James Watt and his partner Matthew Boulton petitioned Parliament to pass an act outlawing the use of such engines as a public danger. Protecting people from harm has increasingly been a focus of many fields of engineering since the 19th century. Over time, engineers began to propose design changes and build in innovations to reduce risk, and thus the industry of safety engineering was born. Safety engineering deals with accident prevention, reducing the risks associated with human error, and integrating safety benefits into engineered designs. The purpose of safety engineering is to control risk by reducing or completely eliminating it. It also aims to reduce the rate of failures, and if failures do occur, that these are not life-threatening. This work has led to the development of safety codes and standards governing technology design, including the use of natural gas and electricity, the building and use of steam boilers, and the storage and use of explosives. Engineering societies and institutions like the IMechE, whose original charters stressed the promotion and facilitation of the profession's work, were, by the mid-20th century, beginning to impose safety as the primary moral duty of the engineer. Today, there are many engineers whose work is devoted entirely to the protection of the public and workers from the hazards of technology and natural phenomena, such as fire protection engineering and automobile safety. Today, these engineers often make use of computer models, prototypes, or recreations of situations to assess potential hazards and risks, such as crash testing, and consider not only the situation or use of the product, but the design processes applied, the material reliability, legislation, and even human factors. The intertwining of engineering and safety will undoubtedly intensify in the future in response to constant rising public expectations and the ubiquitous use of technology in our lives. So how can we make those risks as low as reasonably practicable? In this month's episode, I discuss why safety and reliability play such a key role in engineers' decision-making processes, the need for safety legislation and its impact, and how engineers mitigate risks using ALARP, with my guest, Chartered Engineer Keith Miller, Technical Safety Consultant and one of the lead authors of the IMechE's ALARP for Engineers Guide, published in 2021. Keith, thank you for joining me today. I opened the show with a potted history of safety engineering and how it came into being. Of course, there is much more to it than that, what we don't really have time to go into today. But where I would like to start is by asking you about how safety engineers measure and regulate their decision-making processes. Because here in the UK, we have very strict regulations and legislation on safety and risk, don't we? So could you tell us a little bit about that?
Yes, good morning, Helen. Hi, and certainly I can answer that. So UK legislation basically requires us to reduce the risks to as low as reasonably practicable, or ALARP as is commonly known, sometimes known as so far as is reasonably practical. The two terms effectively mean the same thing for our purposes. So there's two ways we can go about doing this. The first is a numerical approach, And the second is what I like to call a well-reasoned argument. So if we look at that numerical approach first, let's say we want to travel by road or by air. Now, there are good statistics for both of those options. And we also know the costs of doing both. So we could look at the differences in the risk and the differences in the cost. And if we divide the cost by the risk difference, we effectively get the cost of saving a statistical life, which is a fairly difficult concept because we then have to put a value on a life and say, have we exceeded that? Is it going to cost more than the statistical life is worth or less? If it's less, then you would go ahead. If it's significantly more, then you might be able to argue that this is grossly disproportionate to the risk that we're removing. That's a nice, simple way of doing it. But unfortunately, as engineers, we don't always have that luxury because we're developing unique systems, and unique systems don't have statistics. So we have to go more towards the well-reasoned argument basis. And what I mean by that is we would have to understand the causes, the hazards involved, and the consequences if those hazards are realized. And then we can start to structure an argument. And my criteria for this is to say, would I be prepared to stand in a court of law and defend my argument given that we'd had an accident? Because there's always an element of risk left over, so it's always possible. So we need to defend that. And I think that's the bit that possibly most engineers struggle with, because making a legal argument is quite tough. But it is basically just like writing a technical report and including all of the relevant information and gathering it together. So most of the time, that's what we do as engineers. We need to structure our case for safety, which is a well-reasoned argument.
So we have to try and be as objective as possible, then, don't we? This is not just a subjective kind of approach to solving a problem, but we really have to think about every aspect of what goes into the engineering that we do. Is that right?
That's correct. So what we need to do is try to find a very structured approach to it, which is systematic and fairly scientific. So in brief, what we do is we need to answer a number of questions: what, where, when, how, and why.
Right.
So if you've answered all those questions, you've probably got your solution. So that might start off with a brainstorming session where you would look at your system and then look at it from a number of different perspectives. We might ask what kind of energies are involved in this system. For instance, we might have pressures, temperatures, or radioactive material or whatever. Then we'd look at maybe what type of equipment and how that equipment could fail, what the failure modes are. We might look at the life cycle stages, so whether we're in construction, operation, maintenance, or even decommissioning. And ultimately, we'd look at how people can be harmed by those activities. And so we've really answered the first three questions: the what, where, and when. And let's take an example. We might be looking at, say, a flap on an aircraft wing as we're coming into approach. So the question would be, how can things go wrong? We know that if there is some hazard with using the flaps wrongly. So the next stage is to ask, how could it go wrong? And to do that, we might ask a series of questions like, what happens if we don't put the flaps down? What happens if we put too much flap or too little flap? Whether we do it too late or too early? Or what would happen if we pressed the wrong button and we didn't put the flaps down, we put something else down instead? So that gives us all the possible means of how it could go wrong. And then some of those would be fairly innocuous, but others could be quite seriously critical to the safety of the aircraft. So we then need to look at why we might do those things. And the why is perhaps the pilot doesn't have enough time to think about what he's doing. Perhaps he doesn't have the competency or the knowledge to go through those things, or perhaps just the layout of the control panel is very badly put, and it's difficult to know which switch to press. Perhaps the switch, they all look alike. In the Second World War, we had problems with people doing this and putting the wheels down instead of the flaps or something. And in the end, they decided to make the switches look like the wheels or look like a flap. So the pilots never made the mistake again. So those sort of things. And in most cases, once we've done that analysis, the solutions can be fairly obvious. But if we haven't solved it, then we go through a thing called the hierarchy of controls. And there's sort of 5 levels to the hierarchy.
Okay.
The top level is elimination. So we would ask, do we really need flaps on the aircraft? Can we take them away?
Yeah.
The second level would be substitution. So we would say, is there something else that can do what the flaps do instead? And the third level would be an engineering solution, perhaps, that might say we'd have an alarm on the flaps. So if we tried to lower the flaps at too high a speed, an alarm would call.
Right.
And of course, what would happen if the alarm failed and we didn't realise? So then the fourth level is procedures and administrative controls, where we'd write strict procedures for the pilots to follow. And the fifth level, the lowest level, would be to provide the person with protective equipment.
Yeah.
And so in the case of an aircraft, you might give him a parachute. So that's your absolute last line of defence, really. So that's basically what we go through. And once we've done all of those things, we should be able to solve all our problems and make things safe.
That's a really good way of sort of thinking it through, because at each stage it gives the engineer the opportunity to mitigate the risk, doesn't it? And that's how we describe it, don't we, as engineers? We're mitigating the risks. So I think that's a really good way to explain to some of our non-engineering listeners who might be, unsure about how we solve those problems. But the growing complexity of technology, the built environment, our natural ecosystems, engineers can no longer kind of rely on paper and pencil and a finger in the ear like, perhaps James Watt did back in his day. So what kind of tools and technologies do engineers use today to enable them to measure if a system or a situation is safe enough?
Yes, I think this is really the core of the problem that we've found. Is it is actually very difficult to say whether something's safe enough. And what the law is asking for is not what the level of risk is, but have you reduced it as much as you can, or as much as is reasonably practicable. And from a technical perspective, trying to predict the risks on a complex, perhaps socio-technical system is fraught with difficulties. So there's a thing called the risk prediction paradox. And what this says is that accidents only happen because of something we don't know. And you can't model something you don't know. Yeah. So, but if you did know it, then you could solve the problem. And that is really the dilemma we're faced with. A good example of this is the 3 Mile Island nuclear accidents that happened many years ago. And it happened because there was a feedback loop that was giving false information. Now, an engineer could determine whether the feedback loop was functioning correctly and solve those problems. But it's not something that a mathematician could do. So the mathematician will only model the system as the engineer tells him to. So he's modeling what the engineer believes. So ultimately it becomes a circular argument. The engineer briefs his beliefs. The models then tell him what his beliefs were, and it's effectively a circular argument that you've created. And that is a real problem, because you've missed out the bits you're looking for, the problems, then the model will give you a false sense of security. Yeah. And that's why many accidents have happened because we've created this false sense of security. And once a complex computer program has told you that something's safe, you're not likely to dispute it. But the question is, most people don't understand the complex computer program, so they don't really know what it's telling them.
Yeah.
And we see these sort of principles in many accidents, like Fukushima, the Boeing 737 MAX 8 accidents that recently happened. And Ladbroke Grove train crash was a classic, where they'd used these models to determine the risk was low, and they couldn't justify putting an automated train protection system in. And then shortly after Ladbroke Grove, we had 31 deaths and 250 significant injuries. So it is a big problem that we've found, that you need to go through these thorough processes. And so any probabilistic model can only model random data, and accidents are not random things. So we've got serious concerns about this, but it's happened because industry has got this belief that we've got to quantify risks, and we don't have to do that.
So I guess in some respects, we've built up these models, we've built up complex mathematical models that can only really be solved by computers. And we're now finding, I suppose, that we can't really put a complete trust in just an algorithm, can we? We've got to use our understanding and the human nature side of who we are as engineers to problem solve. Is that really what you're saying?
Absolutely. I think someone once said an algorithm is just an opinion embedded in code. And so it is quite a dangerous thing unless you really understand it. And of course, what we're doing is subtly different to what you see on social media and all these other programs, which look at sort of mass data and try to find profiles in it and then profile all of us and send us messages accordingly. They're successful most of the time, and they work a percentage of the time, so they work from a financial point of view. But as engineers, what we're trying to do is we're trying to find the 1 in a million accident that we're not expecting, and that is a completely different concept. So you can't use the same principles as you use with big data, as we say these days.
So, Keith, let's turn our attention then to the ALARP for Engineers technical guide, which was produced by the IMechE last year. You played a leading role in producing that document. Why did you and the Safety and Reliability Group feel this technical guide was necessary now? And what impact has it had on the safety engineering community in the UK?
Yes, I think the problem is that there's an awful lot of guidance out there now that's been developed, which encourages risk quantification, this concept that we need to know what the risks are. So industry seems to have got stuck in a mindset, and there's nothing out there to counter it or to correct it and inform people what their legal obligations are and what is technically feasible and what is not technically feasible. So that was really the driving force behind it. And there were a number of other things. We wanted to make the whole process more scientific and rigorous and get rid of some of the ambiguities in it. So they were our reasons. You also asked me what impact it's had on the safety engineering community. I think to a degree it's split people, because there are a huge number of people that agree totally with the document and have supported it. But there's always an element of us that believes we can quantify risks in some way. It's a natural sort of aspect of human nature. We, right from going back to finding food, would try to avoid the predators that would eat us. So it is implicit in our nature, but we can't do that with complex systems. And it's a difficult concept to get across, but there are a lot of people who've been involved in this for a long time, and it's quite a difficult pill to swallow if you've been building these models, to be told that they're perhaps not very sound at all, really. So yes, it has split people, I think. into sort of two groups. You either believe it or you don't. Mm-hmm.
Well, I mean, this is the nature of engineering, though, isn't it? In general, that new concepts, new ideas come along, and sometimes it can take time to be accepted or integrated into our psyche as engineers, I suppose. And that's, I suppose, an understandable thing. Do you think over time it will become a more accepted approach to this kind of problem solving?
I hope it will, and I think that's what our long-term objectives are. For me personally, I think that what we need to do is get an informed debate going and develop policies to explain to people what is acceptable and what is not. And that's a difficult one. And I think the problem mainly is probably we can quote Max Planck, who said, science progresses one funeral at a time. And as Thomas Kuhn said, that basically we have to have a crisis before we move on. And so our beliefs remain as such until someone proves us wrong. And he quotes things like Copernicus, who realized that ships weren't arriving at the right ports, and so he recalculated the astronavigational formulae on the assumption that the Earth goes round the sun and not vice versa, and all the ships arrived at the right ports. And so everybody said, well, he must be right then. Once you've got empirical evidence, then people start to believe you. But what we have here is something you can never prove wrong. If I say a nuclear power station will blow up once every million years, there's no way you could ever prove me wrong. So we need, the only way forward is that we all accept that we need an intelligent debate, an informed debate about this with all the relevant parties. And I think if we were to do that, develop a set of guidelines, policies for how all of this stuff should work properly and get those accepted, then it would be a very powerful tool that would extend much beyond just the safety environment, but all sorts of other issues such as environmental issues and many of the other aspects of engineering.
Yeah, I absolutely agree. I think that this is something that's not just focused on building pieces of technology. It could cover so many other aspects. I work in the healthcare engineering sector, and the impact that engineers have now with all the technology that is surrounding a patient can have a significant impact if something goes wrong.
Yes.
And it could cause death. So what you're saying is very much at the forefront of my mind as an engineer in making sure that I mitigate as many risks as possible in the technology that I help to design and build, so that I know that it's going to be safe for that patient at the end of the day.
Absolutely, yes. Mm-hmm. And I think the medical world was transformed by statistics, wasn't it, originally, when they started to use statistics to understand what worked and what didn't work. And it was very difficult for that to be accepted in the medical community. So, but equally, it has a good side, which can be tremendously beneficial. But if we take it too far and start thinking that we can calculate things that are not reasonable, it can have a downside as well.
Absolutely. So looking to the future then, safety engineering is clearly going to be playing a leading role in addressing many of our global challenges, both natural and man-made, that you've mentioned today. What role will ALARP play in that future, and what changes do you envisage taking place to improve our ability to predict and mitigate risks?
I think we've covered the sort of problem areas, and I think there's new technologies coming out, the methodologies that are now coming onto the scene, which the uptake has been very slow. But we need a more, I think, broader view on the subject. A lot of industries have their own processes, and they're very blinkered in some cases that, like the chemical industries use HAZOP, and there is a kind of mindset that HAZOP, once you've done a HAZOP, maybe you've done it. Well, no, you haven't. And there are other things to it. And so what we've tried to do with our document is to try and create that broader mindset that applies across the board, so people will work from first principles rather than just religiously following one methodology or another. So I see that as potentially very beneficial, and hopefully, so long as we can remove the sort of false notions of low risk and things like risk matrices, which are just guesswork, frankly, we can make the subject more scientific and hopefully prevent more accidents in future. So I think that's the way forward.
I think that definitely sounds like the way forward. And as you rightly said, it takes time for people to accept change. But it sounds like there's a really important debate to be had here, and certainly something that could have the long-term implications of changing the legal requirements for safety, and engineers are going to play a big role in that. So Keith, thank you so much for joining me today. It's been fascinating to get to understand a little bit more about why, as engineers, we have to take so much responsibility in ensuring that people and the surrounding environment are safe in whatever it is that we do. Thank you very much.
Well, thank you, Helen. It's been a pleasure.
Engineers work in many disciplines, but all of them have the ability to affect societal well-being to a very significant extent. The privilege of having the skills and knowledge to contribute so much to such important areas of life clearly bring with it the need for wise ethical judgment when exercising that privilege. A quote from the Engineering Ethics in Practice, a Guide for Engineers, from the Royal Academy of Engineering, 2011. With great power comes great responsibility, and as engineering professionals, we exercise significant power over the decisions we make on behalf of society every day. Just like doctors, engineers are faced with ethical dilemmas where they can find themselves making life or death decisions. Engineering ethics is a growing field of study that looks at the moral decision-making that applies to the practice of engineering. The field examines and sets the obligations by engineers to society, to their clients, and to the profession as a whole. Engineering professionals work to enhance the well-being of everyone, and in doing so, they're required to maintain and promote high ethical standards and challenge unethical behaviours. There are 4 fundamental principles for ethical behaviours and decision-making, outlined by the Royal Academy of Engineering and the Engineering Council, which include honesty and integrity, respect for life, law, the environment and the public good, accuracy and rigour, and leadership and communication. As a professional body, the IMechE expects its members to maintain high standards of ethical conduct, which require us to protect members of the public, protect IMechE members, and uphold the reputation of the institution and the wider engineering profession. To achieve this, we have a code of conduct which outlines these requirements and to which members are expected to abide by. In the second segment of today's show, I speak with Fellow of the IMechE, past trustee and council member Matt Garside to get a personal view of the importance of ethics in engineering, why engineers should use their privilege wisely, and how engineers will safeguard society in the future. I started by asking Matt what the term engineering ethics meant to him personally. Matt, thank you so much for taking the time to talk on the show today.
Thank you very much for inviting me, Helen. The opportunity is very much appreciated.
When people think of engineering, they don't necessarily think of ethics or ethical implications, do they? So what does the term engineering ethics mean to you personally as a chartered professional engineer?
That's an interesting question. Ethics for me is considered part of a field of philosophy. And so Louvre in Paris has got a black Babylonian column that outlines the code of Hammurabi, which outlines a code that dates back to around 1750 BC. So in a sense, our own morality has been around for quite some time. But for me, kind of thinking about it now, acting ethically boils down to maintaining our professional integrity.
Yeah.
We should always be doing the right thing when no one's looking, which kind of links into values and behaviours. We do this by adhering to a set of rules and guidelines regarding our moral obligations to our profession and the wider society. The majority of my career to date has been in the nuclear industry, so safety is of paramount importance, not just for the site operatives, but also wider society. There have been numerous programmes on Chernobyl, for example, that highlight what can happen when decisions are made to restrict key information, such that those in charge don't fully understand the dangers of a given situation. So we've got to be really careful.
Yeah, absolutely. Well, you and I have worked together in the past, haven't we? So we've both
Indeed.
been on nuclear sites together, and we both know just the seriousness of working in those kind of environments. And so I think you're absolutely right. It really does come down to our integrity, what we hold dear to ourselves, I suppose, as engineers.
Yeah.
So I guess it can be a very subjective thing, really. It's what I've just been talking to Keith Miller about is the objectiveness of making decisions in terms of safety, but ethics is really about our personal view in some respects, isn't it?
It is indeed, yes. I mean, we've got to be careful. We've got to make sure that we kind of maintain our level of integrity at a good level. There'll be different lines in the sand as to what is acceptable or isn't acceptable, and it'll be down to individuals to kind of come to that view as to what they think and perceive to be the right thing.
Yeah, definitely. Now, the Engineering Council published its updated statement of ethical principles in 2017, which has 4 fundamental principles on ethical behaviour and decision making. Now, obviously, they're all equally important, but which one of those stands out the most for you, and why?
Well, for me, it's down to honesty and integrity. I think is the foundation. Really, it's the essential building block.
Yeah.
It permeates throughout the remaining 3 principles, which are respect of life, law, the environment, and public good, accuracy and rigour, and leadership and communication. So, like you say, they're all really important. However, the fundamental building block for me is honesty and integrity. Honesty and integrity is key to engineers being a trusted source of knowledge and advice, whether we're at a project level or more strategic, higher level.
Yeah.
And personally, I don't believe that an engineer would be able to reach their full potential if they're operating without honesty and integrity.
Yeah, absolutely. And I'll make sure that I put some links, by the way, to the Engineering Council's ethical principles document. It's often something that I talk to young engineers, and they've never seen it, they've never read it. So I think it's something that's very important to all of us, really, and we ought to share that information with everyone.
Oh, absolutely, absolutely, and it links in with our 4 I's as well in terms of integrity. So it could be good to link into that in terms of our code of conduct as well.
Of course, yeah. And as with all professional engineering institutions, the IMechE has a code of conduct which all members are expected to abide by. Why is it so important for us to have that kind of document, Matt?
Well, the IMechE code of conduct is vitally important in my mind. It sets out behaviours that we can expect our members to exhibit on their day-to-day activities and interactions. It's essential that we protect members of the public,
Yeah.
our members, and uphold the reputation of the IMechE and wider profession. I mean, just as a slight aside, we had a booking that somebody wanted to book out some of our facilities, for example. And through looking through some research into their background and their organisation, we found that they were quite key deniers of climate change.
Right.
So, from an ethical point of view, the decision was taken by our executive that actually they would decline that booking. So, it's very important that we will get bombarded with these things day in, day out. But it's key that everyday interactions are kind of where we hit it on the head.
Yeah.
And fundamentally, also, if we didn't have a code of conduct, we wouldn't have a line in the sand as to what we believe would be acceptable that members can be aware of and follow. And without that line in the sand, we'd find it very difficult for our members to be assessed in a fair and consistent manner if there was ever a complaint raised.
Yes, because as we were talking before, again with Keith in our previous interview, the responsibility of engineers is becoming so complex these days that to be called up in a court of law or to be caught up in some kind of litigation is something that's now becoming fairly commonplace.
Mm-hmm.
So we have to have these kinds of standards, don't we, as professional
Absolutely.
engineers, to be able to set our standards against.
Yes, and that's why with our code of conduct that we reviewed a few years ago, that we've come up with some simplified advice. We've also updated our disciplinary regulations as well in line with that to ensure that we have a consistent approach and it's all up to date with latest best practice.
Yeah, and that's the key, isn't it? Is keeping things up to date and regularly reviewing them so that we are leading the way in terms of
Absolutely.
our standards and our knowledge.
Absolutely.
Now, what legal responsibilities do engineers actually have? Are there any kind of, or is there any kind of legislation which engineers can refer to on ethical problems? And if not, do you think it's needed?
Oh, that's a good question. In terms of engineers, I mean, I find that they're duty bound to adhere to the laws and regulations that apply to their kind of specific country or region.
Yeah.
However, in the UK, we're not like countries such as the United States of America, where over there they've got a legal requirement for an engineer to be licensed, and we don't have that in the UK. And I think there's a subtle difference that's good to understand in terms of a difference between legal requirement and ethical standards. Legal requirements are covered by legislation that's been set by the government. Police are then empowered to enforce those rules. And a topical example at the moment are the lockdown legislation and the rules during 2020 and 2021 that many of us adhered to, but there may have been a few that didn't. And we've seen numerous fines for a variety of different people. So I'm not aiming it at anybody in particular. But also, when we look at the ethical standards side of things, as far as I'm aware, they're not covered by legislation. It's more of a case of individuals understanding what's right and wrong and then acting in the right way. Key example of ethical behaviours, in my own opinion, is the fact that several multinational companies decide to either reduce or stop completely any work associated with Russia.
Yeah.
Mainly because of the current crisis in Ukraine. Now, that kind of triggered myself into my own thinking in terms of the institution's investments. And having asked the question, whilst we're not on the same financial scale as these multinationals, I'm pleased that when we reviewed our portfolio, we confirmed negligible investment through Russia, as we've put in the annual report.
Right.
And also, bearing in mind the field of ethics has been around for so long, I think it'd be quite difficult to cover all scenarios using legislation, which at times can be quite a blunt tool or blunt instrument. However, it can be said that compliance with relevant codes of conduct is part of the process that somebody would evidence their commitment to complying with the law.
Yeah, and you make a good point there as well. It's because it's not just about what we actually do in terms of our day-to-day job as engineers, but actually, being responsible in terms of what we do to represent our community of engineers and to protect society, wider society as well. So having a stance on these things that are going on in the world is very important for us as engineers as well, isn't it?
Oh, absolutely. And, when we're away from the office, it's not just a case of being ethical when you're in the office. Numerous people will have probably experienced having to write or read and sign to say that they've read an ethical brief of some description to prove that you're not going to go away and start trying to bribe customers to give you more work, etc. You're not going to start offering work to family members who might run companies or be involved in other companies. And it's for those very reasons, when you look in things like the annual report, we do have a few statements in there in terms of related parties. Helena Rivers works for ACOM, and ACOM have done a little bit of work for us from time to time from a design perspective. So those kind of things need to be logged so that we're completely open and transparent with our members.
Yeah, absolutely. Now, in my intro to this segment, I quoted a statement from the Royal Academy of Engineers Engineering Ethics in Practice Guide, which talks about the privilege engineers have in terms of affecting the lives of others and the responsibility that brings in terms of gaining the public's trust. Do you think we as engineers recognise the value of that privilege, or is there more we should be doing to understand its importance? And also, I suppose, how crucial do you think that bond of trust is today with wider society, particularly as technology is becoming far more ubiquitous?
Sure. Well, as engineers, I think we understand that what we're trying to do is to do something for the benefit of wider society, no matter what industry we're in.
Yeah,
And privilege comes in many, many different forms. And in a sense, every person, let alone engineers as a subset, has a virtually unique set of privileges. I mean, some of my own are quite wide ranging, such that, I've got an engineering degree, I'm chartered, I can drive, I have a vehicle, I have pets, etc., etc. So
yeah,
privileges. I mean, some people in the world don't have any of those things, and I think it's key that everybody, not necessarily just engineers, use and understand their privileges to begin with, and then look at how they can use that to assist others by giving back, if you will.
yeah.
Which is one of the reasons why I've been actively volunteering with the IMechE for over half my life, which is about 21 years. And I'm also in discussions with other charities. I volunteer for Mission Motorsport as well. And I'm looking into potentially joining their trustee board at some point in the future as well, to
Right.
try and help them with the wounded, injured and sick servicemen and women who don't get the support we need from our government when they kind of transition into civilian life.
Right.
And privilege can be quite a difficult topic to talk about in an open manner. There may be a fear of accidentally causing offence, making people feel uncomfortable by discussing their privilege as from your point of view, and potentially them being judged as well.
Yeah.
And one of the things I've learned through the IMechE's recent diversity and inclusion training program is the key that we create a safe environment for people to speak up, but key also for them to only speak about what they're comfortable about.
Yeah.
It's important that we reflect internally so that we understand how our privileges can be used to a positive effect for others. And I believe that the need for society to trust engineers is now really strong. A good example is how we're driving towards electric and more specifically autonomous cars. If we can't get the wider public to trust that the design work, the hardware, the software, etc., will keep them safe, then the rollout of the technology will be much reduced, much, much slower, which could affect people that would actually benefit from early adoption, such as people who currently are unable to drive or don't have a vehicle. They may have a medical condition, for example, that prevents them from driving, which an autonomous car would give them a great sense of freedom.
You're absolutely right, Matt, and using that privilege to its best advantage can really improve not just our own lives, but many lives elsewhere in the world. And I think it is a very important part, particularly of our diversity and inclusion, as you rightly said. So I've mentioned Keith's name a couple of times while we've been talking, but I was speaking with Keith on ALARP, and I asked him the same question that I'm going to ask you, but I'm going to reframe it slightly. Looking to the future, ethical principles and behaviours are really going to play a prominent role in an engineer's working life. How do you envisage what that will look like? And what do you think engineers can be doing today to safeguard society for tomorrow?
Well, yes, another good question. Whilst I don't believe fundamentally that the kind of ethics as that kind of field of philosophy has changed much in recent years, obviously it's been around for so long, I think the number of scenarios that engineers experience on a regular basis is increasing exponentially as we kind of go forward. So some examples could be a matter of personal preference, so choosing a specific diet, fitting solar panels to your house, for example, to become a bit more energy efficient and self-sufficient. But they all kind of relate to a person's moral code as what they feel is the most important thing to them.
Yeah.
And I think in the future, I expect many more scenarios that engineers will have to negotiate. So go back to the autonomous cars example. There may be a need to agree some kind of universal approach or hierarchy for certain hazards. We've all probably seen Jeremy Clarkson mention about, well, what happens if the car approaches in a scenario and somebody's going to get hurt from a potential accident.
Mm.
Who does it protect over and above whoever might get protected the worst? And if you've seen the rules changes to the highway code in the UK, where there's a hierarchy of priority
Yeah.
to people who are more vulnerable, then again, those kind of things will all kind of fit in, and it will rely heavily on vehicle manufacturers. Whilst they might have their own intellectual property, in terms of what they've devised and what they've designed, is going to rely on a lot of sharing of that information. So we understand how the different cars are going to act. It'll be a terrible situation we'd be in if car A costs twice as much as car B, therefore car A gets priority in every single circumstance that comes out on the road. That would be completely the wrong thing, in my own personal opinion, to be doing. And what I'd like to think is that, a bit like health and safety has become ingrained into our everyday kind of psyche and activities, I'd expect ethics and, to an extent, diversity and inclusion to follow that same kind of path, such that we move forward, we act in an ethical manner, and we understand that the pitfalls in the ethical landscape going forward, and we understand a bit better about ourselves, how we're going to navigate that.
I think that's a very good point to make, Matt. And I think as well that it's not something that really gets taught to us as young engineers, is it? It's in terms of our studies, our degrees or whatever. It seems to me that now is the right time to introduce ethics into those training processes, so that every engineer is exposed to it from a very early stage, and is constantly, it becomes part of their everyday thinking. It's not just an add-on to something in case something goes wrong.
Yeah.
So thank you ever so much for sharing your very personal view about the ethics of engineering, and it will ring true with many of our listeners today. So thanks a lot, Matt.
Excellent. Well, thank you very much for the invitation, Helen, in the first instance. Really happy to discuss these kind of topics. I think, like you say, it's becoming more and more important, more and more prominent. And like you say, in terms of trying to get it back into universities, I think, and in terms of apprenticeships and degree kind of learners, I think it's key, because you look at the professions like the law, medicine, etc., and the ethics has actually got quite a stark statement and a stark place and position within those professions. And I think it's about the right kind of time to be thinking in terms of the engineering sphere. Well, do we need our own version of some kind of Hippocratic oath? Do we need some kind of entry level information that will help people make these kind of ethical decisions that they're going to get bombarded with in the future, to help them develop further? Absolutely.
As with doctors and nurses, engineers have a responsibility to do no harm. And I think that's an important point to end today on. Thank you ever so much again, Matt.
Excellent. No problem. Thank you very much, Helen.
This month, we will be bringing you an extra episode from the Railway Challenge, held at the Stapleford Miniature Railway in Leicestershire. Now in its 11th year, the Railway Challenge brings together teams of young engineers and apprentices from across the railway sector to test their technical skills, engineering knowledge and business acumen. So listen out for that at the end of June. You've been listening to Impulse to Innovation, the Institution of Mechanical Engineers podcast. Thanks for listening. We'd love to hear from you, so if you'd like to share any news or any feedback with us, then please email us podcast@imeche.org. All the information on this episode can be found in the episode notes.